are going to see some case studies demonstrating the use of data analytics in process optimization and quality improvement. So, the first two case studies is not with respect to chemical engineering perspective, however, it also comes under the category of process optimization and quality improvement. The case study 1 which I am going to discuss is from automobile, whereas this case study 2 is going to discuss about healthcare industry. The remaining case studies is purely on chemical engineering perspective. So, this is what I am going to cover in today's lecture. Case study 1 talks about the manufacturing industry, reducing defect in production. So, let us assume the automobile manufacturer faced challenges in maintaining consistent product quality due to defects in the assembly line. As you know, any manufacturer will have a lot of difficulties in the production processes. Okay, likewise, the automobile manufacturer faced challenges in maintaining the consistent product quality due to defects in the assembly line. Frequent defects lead to increased rework cost and reduced customer satisfaction. As you know, the product quality is not consistent. If not meet the standards, obviously the quality product cost will be comes down. Okay, so it may be either not only automobile industry, any type of process, it need not be necessarily even chemical engineering, any types of process, the output, that means the product which has been obtained during the process, if the quality wise is not consistent, obviously the cost of the product will be comes down, and it could not able to withstand the quality standard as well as the customer satisfaction. So, in order to overcome these difficulties, how this data analytics will help you actually to overcome these issues. That's what we are going to see in this case studies. Implementation of data analytics. The company deployed machine learning algorithm to analyze the sensor data from production equipment. So, they are deploying the machine learning algorithm to analyze the sensor data from the production equipment. So, if there is any deviation in a proactive measures, it will give an alarm to the people so that we will be alerted why this deviation occurs. The real-time monitoring system were installed to track the deviation in critical parameters such as temperature, pressure and machine vibration. So, underline the word real-time monitoring system, very important to understand and maintain the consistent output. So, this will be a data collecting source where we will give the input to this machine learning algorithm, so that machine algorithm proactively measure the things and will let us know. So, where is the difficulties, how to overcome. So, historical defect data was used to train the predictive models. So, how the system know which data is correct, which data is not correct. So, because of the previous record of what are the data which has been measured during the inefficient production, that data has been given to the system to train the predictive models to identify the early warning signs of defects. So, because of doing like this, we could able to reduce 30% reduction in defect rate was achieved within 6 months. So, predictive maintenance helped prevent machine breakdown, reducing downtime by 20%. Improved product quality resulted in high customer satisfaction and cost saving. So, very important. So, cost saving as well as the customer satisfaction, and then try to find the optimized point actually in the process is very important, because of using the data analytics, actually data analytics and then implementing of a machine learning algorithm will help you to overcome all these issues. Coming to the second point of case study, so where we are just going to talk about healthcare industry. As I told you before, enhanced patient care with data analytics. So, what is the background here? Yeah, hospital network looking to improve patient care by reducing the length of hospital stays and minimizing the readmission rate. So, most of the time, so if you go to the private hospitals, mostly they will ask you to readmit, okay, because the diagnosis is not proper and the length of the stay may be higher, depend on the casualty of your health. Okay, so if in order to overcome in abroad, usually these people have been now started to implement this data analytics and machine learning system, so that will help you the patients not to stay prolonged in the hospitals, as well as not to go back again back to the admission into the hospital. So what are they doing actually? In fact, patient records were analyzed using AI-driven predictive models. Underline the word AI-driven predictive models to identify the risk factors associated with prolonged hospital stays. So, before collecting the data from the patient, what are the why they have been ill, what is the reason for that, and AI-driven predictive models to identify the risk factors. So, when this data patient records will help you to run the system AI driven predictive models, so that it will give you a yearly warning sign if we have the real time data of the patient. Hope you understood this. So electronic health records were integrated with the real time monitoring device. So let's imagine nowadays you have the people who have been running, okay, so they have a pulse rate meter, so they could be able to measure what you call the heartbeat, as well as what you call the pulse and things like that. Okay, so even the oxygen level, okay, in the blood, that can be measured. So there are plenty of sensors which have been available to find out collect the data from the patient directly, okay, without getting into the hospital. So electronic health records were integrated with real-time monitoring devices to track the vital signs and alert medical staff to critical changes. So when the sign is very low, for example during the corona period, okay, the people ourselves, we have been started to test ourselves regarding the DO level, dissolved what you call regarding the oxygen level. Okay, so the oxygen level, if it is lower than 95, okay, obviously we have been alerted, okay, and then we have been guided through what a lot of news, through the news, okay, stating that if it is lower than 90 or 95, obviously they have been asking us to get into the hospital. Okay, so likewise, when you have a what you call data which has been transmitted from the patient side to the thing, obviously if the level is low, they themselves we can directly contact the patient and ask them to come and join immediately. So this is the way. So when you have the electronic health record, we are integrated with the real-time monitoring system, so that will help you to identify the patient's health care, okay, then and there, and obviously we can give a alarming note to the patients. So that's why this system will work. Data-driven decision support systems were implemented to personalize the treatment plan based on historical patient data. So previous data, that also we could be able to collect it and keep it ready. Okay, so because of that, a 20% decrease in patient readmission rates was observed. So the length of hospital stays was reduced by an average of 1.5 days, freeing up hospital resources, improved patient care, and operational efficiency lead to higher satisfaction scores from patients and healthcare providers. Obviously, if it is very small, especially in healthcare, not only in healthcare, even in manufacturing, whenever the deviation occurs at the initial stage, if we try to find it out, then it will be easy to sort it out. Otherwise, if the healthcare is more significantly damaging, for example cancer, okay, if you yearly identification of cancer at a stage 1 or stage 2 will help you to prolong the lifespan of the human, okay, those who have been affected with cancer. If you go for the stage 3 and stage 4, that is not easy, okay, to recover back to a normal or to postpone the death. Okay, so far nobody have given a remedial medicine, okay, to recover from the to recover the cancer patient. However, we could be able to postpone the death. Okay, so why I'm trying to say this one, so that whenever you are finding out the deviation at the early stage, that will help you to protect these things, not only in terms of healthcare, even in the production as well. Okay, so this case studies, the case study 1 and 2, first one which we are talking about is the automobile industry, the case study 2 which we are talking about is the healthcare. This case studies highlight the transformative impact of data analytics in optimizing the process and improving the quality across industries. By harnessing the power of data, business can make informed decision, enhance operational efficiency, and deliver superior products and services. As data analytics continue to evolve, its role in driving innovation and continuous improvement will only grow stronger. Coming to the case study of 3, which we are going to see in terms of chemical engineering perspective. Data analytics has become an essential tool in chemical engineering for optimizing the process and improve the product quality. So very important for chemical engineering, optimizing the process that will try to reduce the cost of the process. Obviously, when you try to reduce the cost of the process, obviously the cost of the final product will be comes down. Okay, and the optimized thing will give you a higher efficiency, higher yield, okay, and also improve the product quality with a good standard. Okay, by leveraging the data-driven insights, chemical industries can enhance efficiency, reduce waste, and maintain stringent quality control. The following case studies illustrate the practical application of data analytics in chemical engineering. So let's see the example for optimizing the reactor performance in petrochemical industry. A petrochemical plant faced challenges in maintaining the optimal reactor conditions, leading to variable product quality and high energy consumption. Okay, so is petrochemical industries. So petrochemical industry, the petroleum products which has been used as a raw material for the petrochemical industry. So when you want to operate this petrochemical industry for the production of petroleum petroleum refinery petroleum products, okay, the petroleum derived products, okay, like what you call char, polyethylene and things like that. Okay, now, so in order to during this process, optimal reactor condition is needed in order to have a high yield as well as the optimal high yield, okay, and then lower energy consumption. Okay, leading to a variable product quality. If it is not being maintained, that will leads to a high energy consumption and variable product quality, which is not needed. Okay, we want a consistent product quality. Okay, implementation of data analytics. So how to deploy the data analytics system to a real-time thing. Advanced process control system were integrated with real-time data analytics to monitor the reactor condition. So right now I would like to give an example during my experience. Okay, when I was working at CSER NEERI, I used to collect the data weather monitoring system actually from CPCL, Chennai Petroleum Corporation Limited, because I was deputed there for almost 6 months to measure the weather monitoring and also to measure the pollution level which has been created by the industry. So during this time, I used to collect the data for which direction the wind is blowing, actually what are the amount of concentration which is coming out from the exhaust of the industry. So the real-time monitoring will help you to predict how the dispersion of modeling takes place, dispersion of pollutant takes place by modeling has been carried out. Okay, so similarly here the advanced process control system, when we are integrated with the real-time data analytics to monitor the reactor condition, so that we could be able to understand what are the variables which has been changing during the process time to time. Okay, predictive analytics was used to optimize the reaction parameters such as temperature, pressure and catalyst concentration. Historical production data was analyzed to identify the patterns that contributed to inefficiencies. So the previous previous data which has been collected, and it has been proved that because of this particular data, okay, leads to during this particular data collection time, that because of that particular data, relate to the product quality, when you collect that particular data, that will help you to understand, okay, we are not supposed to get this type of data deviation, okay, or similarity, not deviation, similarity, so that we could be able to avoid the optimized deviation from the optimized point. Hope you understood what I am trying to say. Okay, so by doing so, implementing the advanced process control and predictive analytics and historical production data, once you collect it, okay, which will give a system given to the algorithm, I mean AI algorithm, okay, so that will help you to overcome these difficulties, so that a 20% reduction in energy consumption was achieved. So for this case, okay, production quality variation were minimized, leading to improved consistency, predictive maintenance, reduced unplanned downtime by 30%. Okay, so the downtime period is the industries is not working, so they will try to do the maintenance during that period, and most of the time as an engineers we will try to learn the process only during the downtime period, because we could not able to see the whole picture of the equipment unless it is in downtime period. So but however, downtime period is a very big loss for the company, that you are aware of it. Okay, so that we already covered in different modules on elaborately on this content. Okay, now our objective is to find out how this data analytics is helpful, okay, in process optimization and quality improvement. Coming to the case study 4, quality improvement in pharmaceutical manufacturing. A pharmaceutical company encountered issues with the batch to batch variability. So it need not be necessarily the same consistent of product which may comes out, okay, in a batch to batch, because in a continuous process, okay, obviously there is a lot of chances you will get a consistent output. But when you have batch to batch, if there is small variation occurs, okay, in a process, okay, obviously that will be reflected back in a output of the batch process. So we should be very careful in censoring the data. Okay, so a pharmaceutical company encountered issues with batch to batch variability in drug formulation, affecting regulatory compliance and product efficacy. So the implementation of data analytics, chemometric models. I will take this class about the chemometric models, how to do the chemometric models. Okay, now we understand there is a one model which will be developed to analyze the raw material variability and its impact on the product quality. So it need not be necessarily the raw material will having the same quality, to analyze the raw material variability and its impact on the product quality. Because sometimes if you see, even the petroleum refinery plant will face a different types of challenges when they try to explore the when they try to obtain the crude oil from different countries. Because in India we always have some higher amount of hydrogen sulfide content, okay, in a crude oil. But if you go to some different countries like Malaysia and Iran, Iraq, Venezuela, because in India we have been buying the raw crude from abroad actually. So if the characteristics of the raw material itself is varying, obviously the output will vary. Okay, so the process will still remain the same, but will not give a consistent output because of the change in variation of the raw material. Okay, so the chemometric models will develop to analyze the raw material variability and its impact on the product quality. So the real-time process analytical technology was employed to monitor the critical quality attributes during the manufacturing. Machine learning algorithms were used to predict the batch failures and suggest the corrective measures. So hope you understood, machine learning algorithm was used to predict the batch failures and suggest the corrective action. So this one you need to train the system by giving an input. So obviously it will give you a predict the thing why it is not matching with the expected outcome. Okay, so when you try to do by this using a machine algorithm, a 25% improvement in batch consistency was achieved for this case study, and a regulatory compliance was enhanced through a real-time quality monitoring, reduction in waste and rework cost by 50%. So coming to the case study of 5, waste reduction in chemical processing. A specialty chemical manufacturer struggled with excessive raw material waste and inefficient resource utilization. So sometimes what will happen, even excessive raw material waste. So the raw material will not be utilized effectively, and inefficient resource utilization will leads to a, what will happen, the cost, higher cost. So obviously is a loss to the company, leading to a higher production cost. So whatever the waste which has been from started with the raw material itself, again is a cost, added cost to the product. Once the product cost increases, we could not able to compete with the competitor, as well as the cost is more, we could not able to sell it at a higher margin of profit. Okay, so this all need to be think in a very broader way, and how to overcome these difficulties, how to reduce this one. Okay, we can make use of the machine learning models. Okay, and then we will do it, we could able to do it. So that's what they are saying. So what they are doing for implementation of data analytics, data driven process optimization techniques were applied to identify the inefficiencies in raw material usage, and then real time monitoring again of key process parameters enabled yearly reduction of deviation. So these are proactive measures. Simulation models were developed to test alternative process condition for minimizing the waste. So because of doing so, so what they did is that 30% reduction in raw material waste was achieved. Overall process efficiency increased by 20%. So obviously the cost saving is realized through optimized resource allocation. So coming to the case study of 6, corrosion prediction and prevention in chemical plant, very very important point. Okay, so nowadays even the crude oil has been pumped through the pipeline. Just imagine if you have a hydrogen sulfide content in a crude oil, obviously there is a lot of chances of the corrosion of pipeline. So nowadays the people have been put a pipeline of around 2000 kilometers is very common. Okay, so so imagine, so how to overcome this corrosion, not only here, even in defense budget, the people have been started to study because of corrosion when the ship, okay, the defensive ship or the what you call it, the navy ship, naval ship may come to corrosion. Okay, so the thing is that it has been kept in the thing for seashore for a long time and may be corroded. So how to produce a corrosion free material, that is another question. Okay, so just imagine in the chemical process, because the stainless steel has been mainly used, so how to avoid the corrosion in the thing, otherwise there is a chances of even the unit itself is getting corroded and obviously will not give a positive output. Okay, so the chemical processing plant experienced frequent corrosion related failures in pipelines and equipment, leading to safety hazards and maintenance costs. So safety, so obviously if the thickness of the material is reduced because of the corrosion, what will happen, it could not be able to withstand the load. So maybe there may be a blast may take place, if the pressure is higher, buckling effect will take place. This all leads to a safety hazard. Okay, so please keep in mind, so we need to look into this perspective in a very very sensitive manner. Okay, in a chemical engineering perspective. Okay, implementation of data analytics, sensor based monitoring system were deployed to collect the real time data. Again the real time data, underline the word. For all the case study, what they are doing is that they try to overcome the questions. I mean, for all the case studies, they are collecting the real time data by using an advanced process control system. Okay, that is one part. The next one is a predictive analytics models were developed to forecast the corrosion risk. Okay, based on the environmental condition here they have given. So in general, the predictive analysis is very important, and the machine learning algorithm through which we will get the output. Okay, and we need to take a proactive measures. That's what in all the case study highlights. Okay, so coming to the corrosion and prediction point here, predictive analytics models were developed to forecast the corrosion risk based on environmental conditions and chemical exposure. Data visualization dashboards provided actionable insight for maintenance scheduling. So because of doing so, a 40% reduction has been achieved in corrosion related equipment failures. Okay, and then maintenance cost was reduced by 25%, enhanced plant safety and extended equipment lifespan has been achieved. Okay, so that's what we got from this Okay, so what I would like to conclude for this actually regarding the case study. Okay, by harnessing the real time monitoring, predictive analytics and machine learning, chemical industries can enhance efficiency. So very very important, please underline the word, by harnessing the real time monitoring, predictive analytics and machine learning, chemical industries can enhance efficiency, reduce waste and ensure consistent product quality. As data analytics continues to advance, its application in chemical engineering will further contribute to innovation and sustainability. Okay, so I have another 3 more case study. Okay, I will give it to as a material. We just go through it and without referring the things, what are the things you need to do, okay, to overcome these difficult challenges, okay, and then write on your own and then check the answers with the implementation of check the answer with the answer which will be given to you actually in the same case study itself. Okay, so why I am asking you to do is that, so that if you know the problem statement, you yourself can know how to implement this data analytics and machine learning algorithm to bring into the system in order to overcome the challenges which has been faced by the chemical industries mainly. Okay, with this note, I would like to conclude my section, today's section. Hope you understood all the case studies which we are discussing, starting with the healthcare, automobile industry, and then healthcare and petroleum, batch by batch deviation, and so on and so forth. Okay, with this note, I just stop it here. I hope we can see in next class very shortly.